So let's wrap this chapter up by solving a few problems. This video is going to be formula heavy, and in the next one, we're going to use our intuition to solve numericals. So let's get started. Okay, here's the first one. E and F are events such that probability of E is 1 by 4, probability of F is 1 by 2, and probability of E and F, this event, probability of E and F is 1 by 8. And what we need is probability of E or F. This is what we need to find. And here's one more. Find the probability of not E and not F. Okay, so it has two parts. Pause the video, think about it. Okay, so let's do this together. Let's solve the first one. Probability of E or F. That's basically probability of E union F. And we know that this is equal to probability of E plus probability of F minus probability of E intersection F. This is something that we have proved in one of the earlier videos. We know the probability of E, we know the probability of F, and we also know the probability of E intersection F. So now all we need is just to put in these values and solve. So let's do that. Probability of E union F is 1 by 4 plus 1 by 2 minus 1 by 8. Taking 8 as the LCM, this is 8 plus 4 minus 1, that's 6 minus 1, 5. So probability of E union F is 5 by 8. That's it. Okay, I hope you got this right. Let's move to the next one. Probability of not E and not F. So every letter counts. Not E means E dash, not F means F dash, and means intersection. So what we need is probability of E dash intersection F dash. Now, if your concepts for the chapter sets are solid, you might recall that this is equal to E union F dash, which is the complement of the set E union F. I'm going to write this down. That's probability of E union F dash. And you might also recall that in your textbooks, this is called the Demorgan's law. And now let's get rid of the complement. That's equal to 1 minus probability of E union F. And this is something that we have just figured out. So let's plug this here. It's equal to 1 minus 5 by 8, which is equal to 3 by 8. Now for those of you who forgot about the Demorgan's law, here's a quick refresher. So let's visualize. This is your sample space. This is event E and this is event F. Let's call this E and this is F. Okay. So this is going to be E union F. Anything that's either blue or green, that's going to be E and F. Now this law says that this thing, E dash intersection F dash, is the same as this thing, E union F dash, the complement of the set E union F. Now you have the visual in front of you and I'm going to explain why these two things are true. But if you want to give this a shot, pause the video and think about it. Okay, so let's do this together. Let's look at the first one. It says E dash, which means everything outside E. It's going to be this thing, the gray zone, and it's going to be this thing, the pure green zone. These two are outside E, which means they combined become E dash. Now let's look at F dash. F dash is everything outside the green zone, which means again the gray zone and the pure blue zone. And now let's look at them together. We need to find E dash intersection F dash, which means whatever's common between the two things that we've just discussed. So what's common between the two? It's the gray zone. It's not the pure blue zone, it's not the pure green zone, it's the gray zone. So this means what's written here, E dash intersection F dash, that's actually equal to the gray zone. And what's the gray zone? That's everything outside the blue or green zone. Notice what I just said. It's everything outside the blue or green zone, which means it's everything outside E union F. That's exactly what's written here. It's the complement of E union F. It's E union F dash. So hence we've proved that both of these things are exactly the same. So that's your refresher on the Demorgan's law. Let's move to the next problem. Okay. Let's read this one. E and F are events such that probability of not E or not F is 0.25. We are asked, are E and F mutually exclusive? Again, pause the video, try this on your own. Okay. So when are two events mutually exclusive? Events are mutually exclusive when they have nothing in common, which means when their intersection is equal to phi or 0, when the probability of them happening together is 0. So we need to reach E intersection F from whatever we are given. Okay, let's write this down. We're given probability of not E, which is E dash, not F, which is F dash, and OR, which means union of both of them. So we're given probability of E dash union F dash, that's 0.25. And again, we're going to do some manipulation. I claim that probability of E dash union F dash is the same as probability of E intersection F dash. And again, all of this is coming from the chapter sets. And if you want a quick refresher, here we go. So this is our sample space. This is E, this is F. Let's call this E, F, and this is E intersection F. Let's look at the first one. We want E dash union F dash. So E dash means everything outside E, which means the gray zone and the pure green zone. And we also need F dash, which means everything outside the green zone, which is again the gray zone and the pure blue zone. And we need the union of these two sets. So we need everything that we have ticked, which means we need the gray zone and we need the pure green zone and we need the pure blue zone. We need all three of them. And that's actually most of what's on the screen. What we have not checked is this thing, E intersection F. We're saying that we need everything that's outside E intersection F. What we're saying is we need the complement of E intersection F. And that's what's written here. This thing is equal to E intersection F dash. So what we can say is probability of E intersection F dash, that's actually equal to 0.25. And once we have the complement, we can find the value of this as well. Probability of E intersection F is 1 minus the probability of its complement. That's 1 minus 0.25. That's actually 0.75. And what can we say? We can say that the intersection has a probability. The intersection has some value. It's not 0. It's something positive, which means there is an overlap. And if there is an overlap, how can they be mutually exclusive? So what we have realized is that E and F are not mutually exclusive. I encourage you to get your hands dirty, solve a few more of these problems either on Khan Academy or from your textbooks.